Hey guys, welcome back to Algos Explained. My name is David Kim, and this is the video where we go over the algorithm. And we're going to walk through a problem here. Hopefully we get to go through the entire thing. It's pretty short, so it's just maybe the space is not enough here. Anyways, let's go through the algorithm. I'm just gonna touch on the choosy parts, and we're going to go right into walking through this because that's how I feel like it's going to best explain the algorithm anyways. And so QuickSort, we know that it's a recursive function. We know that by this, and of course if you knew the idea of QuickSort, you already knew that it was going to be a recursive solution. Now one thing you might be saying is, okay, hey, there is not a base case or something that seems like a base case, and that is because throughout this whole algorithm we're going to be doing a lot of mutating the original array. I know like in merge sort where you actually create more smaller ones and create new ones and spit them out. In this case, we're not creating new arrays. We're not spitting out anything. We are kind of using the original array, mutating it up, like swapping the numbers. And what we're going to do is we're going to kind of, hone down or what is that, like limit the parameters and kind of narrow our calls that way. You can see here there are two QuickSort calls, and that is going to represent two of the, it's going to represent two, or the left and the right, what I mean. Remember how we were going to create some kind of partition in the middle and then do the left and the right and more cut up in the middle and then left and the right. That's exactly what this guy does. And pivot is just, it actually stands for pivot number. We create a number where we go from the max or the right, yeah, max, and minus left, plus left, okay, plus one in there. And that is inclusive for both max and the min. Partition index we created by running the partition function, the helper function here. And this helper function actually does a lot more than just give us that last partition index. This is actually where all the magic happens in terms of swapping. Remember, QuickSort, the biggest idea was that we swap numbers from left and right, determined by whether they belong on that side or not. This is where it happens. And swap, just the helper function that helps us do that swap. Okay, so let's go ahead and get started in here. What we're going to do first is we know that left and right, we don't need to be given that. When we call the QuickSort function, we just need the array parameter to be given. And why we don't need it? Because first of all, we probably don't want it. I don't want to trust somebody to give us a left and a right, since we don't know which parts of the QuickSort or which part of this array has been sorted already or not. And we guarantee that we don't need it from them by setting it equal to a value here, equal to a value here. So on the first call, if we don't have it, it'll default to 0. It'll default to this array length minus 1, which is the last index of that array. And on future calls, we'll give it ourselves. That will help narrow down the scope of kind of which parts of the array we're going to run QuickSort on again. And so first of all, if left and right, these are kind of representing pointers, we're going to represent those left and right pointers on the partition helper function also. However, if the left and right, if they're on the wrong sides, then we already know that we don't need to run that function. We could just return and be over with that. And so let's go ahead and kind of already see left and right is going to be array minus 1, 0. So let's call that here. Left 0, right, it is array dot length minus 1, so 0, 1, 2, 3, 4. And as long as that is left less than that, we're going to go ahead and create a pivot number. And these are indexes. Pivot number, let's pretend we picked the 4 as our pivot number. Partition index, let's decide that. And of course, after that, really quickly, after the partition index, we're going to use that to kind of divide up the left and the right. So, but before we divide left and the right, we need to make sure we did everything we can to sort the numbers in the meantime. And so that's why the sorting happens within the partition helper function. While left is less than right, and I might get mixed up here. I get mixed up here a lot, but left is less than right, okay. And right now left is 0 and right is at the 4. Okay, good. So we have a couple of while loops here. We have an outer while loop and we have two inner ones and an if statement within this while loop. If this statement is no longer true, we know that we're done with all the swappings that we can do, and we return the left as our partition index. So let's go ahead and look at this. The left is less than the pivot. Is 5 less than the pivot? No, it's not. And so we don't go in there because we pretty much want to swap it. In the end, we want to swap something, but we will continue moving on until we find something that should be. Right now, we found left 5 less than pivot, and it's not. And so because that's false, we don't go in there. So that stays. Right is greater than the pivot. Is that greater than the pivot? No, it's not. And so we caught two good ones right there. And of course, this is just inverse. We're going to find a lot of good pivots here. And so we keep the left and we keep the right. We haven't gotten into these while loops, and we swap those numbers. And so this will be a 1, and this will be a 5. With that said, automatically over here we increase the left and decrease the right. And so this will move, that will move. So the left is 1, right is 3. And we go on. Left and right. This is talking about indexes. It works. Left is the left less than the pivot. This is false because it's equal to the pivot, and so we don't go in there. Is right greater than the pivot? Is right greater than the pivot? That is less than the pivot. That's false. So we go into the swap, and we swap those. Let's do that. 2 goes here, 4 goes here. And once we did the swap, we automatically move the points. And so now this goes to 2, and that also goes to 2. However, the while loop, for some reason, we allow it to do that. We allow the left and the right to be equal. So let's go ahead and check it. Is the 3 less than the pivot? 3 is less than the pivot. Remember, pivot number was 4. Since it is, we move on. We move on. Is now 4 less than the 4? No, it's not. And so left has been left as a 3 index. Right is 3 greater than the pivot. Right, 3 is not greater than the pivot, so we stop there. We don't go into that while loop. And we check, okay, before we do any swapping, is left less than or equal to the right? Left is greater, so we don't qualify for that if statement. We jump out of here, return the left, which is a 3. So our partition index ends up being a 3. Partition index, the result of that function is a 3. And so now QuickSort, our next few calls, or next calls, is going to be number 1 and number 2. And what happens here is the array has been untouched, or as in it hasn't actually been smaller. It's not smaller at all. It's this same array. Oh my gosh, it's already sorted. I just realized that. But let's go ahead and walk through it, because it's not going to stop there. It's going to do more function calls. Array left, what is our left going to be? It's going to be a 3. And so, and our right is going to be whatever this is. Partition index minus 1, so that's going to be a 2. And array here for our second call is going to be the partition index 3, and right is going to be whatever right was over here, and so that is going to be 0, 1, 2, 3, 4. All right. And so now that is going to go in here. Let's see, 3 and 4. We know that there are 2 calls now that is going to happen, but let's take a look at potential pivot and partition indexes. You might have already noticed that on the first case, we're not even going to go through here because left is greater than the right. However, so let's skip that. I mean, this is not going to happen. On this case, the potential pivot is now going to be right minus left plus 1, which means that we're going to be looking from the left to the right. So 0, 1, 2, 3, and 4. So we are going to be looking between here to make another pivot. And that's because we pivoted over here and we know, okay, all of that is either true or not swappable anymore. And so let's see. We're going to pick an arbitrary pivot point here, or pivot number. Let's say we picked 4 as our pivot number, and our PI is going to, we're going to have to run through that. I'm going to erase this because we know that our number 1 call is not going to happen, again, because its left was greater than the right. And so let's go ahead over here, erase this stuff, erase that stuff, get that out. And 4 was our pivot, so left was 3, right was 4, pivot was 4 number, and we want our partition index. Let's see, where does our left start with? You might think, okay, start from there, but no, that is starting all over again. We are now starting with the left over here. So 0, 1, 2, 3, that is our left, and that is our right. And so we'll quickly see how this ends. Is left less than or equal to the right? Yes, it is. Is left less than the pivot? No, it's not. We're not going to touch the left. We're not going to move it. Is right greater than the pivot? Yes, it is. Oh, wait. Is right greater than the pivot? Yes, it is. So let's move it. And the right goes to a 3. And now we go here. Or, well, we go to the while loop again. Is right greater than the pivot? Is 4 greater than 4? No. It is equal, so we don't go into that while loop. Left less than or equal to the right. Is left less than or equal to the right? It is equal, so we swap it. So the 4 does nothing, but the left increases to a 4 and the right decreases to a 2. And so pretty much that happens. And once we go up here, left is no longer, it is greater than the right now, so we return the left as our new partition index. What does that mean for that? Well, this is going to have a number 1 and a number 2 call again, because now this was the outer one, now we create another inner one. So now let's decide what's the left, what's the right of this. First call, array left is going to be the left, which has not been affected by that. It is going to be the original 3, and the right is going to be partition index minus 1, partition index as 3. And when I say the left is not this left new one, is because it is not changed. This left is a variable that's within the scope. When we say left is in here, pretty much what's happening is it's just a number, it's just a parameter, a variable name. As far as this function goes, it is not mutating that left value. And for this call here, the call number 2, left would be the 4, the full partition index. The right would be whatever that was, so it's the 4. And we know, we can see right here, both of them are equal to each other, which it will not allow us to do that. And so off of this call here, it is going to return that. And since we don't have a return in front of here, I mean, it doesn't matter if those return anything, they're not going to go in. As in, these guys are going to try to call, but they're going to get stuck right here, skip it, and return an array. So this is like, it does nothing. This does nothing for the array, and we return the array as it is in this form. And so that happens to be the end of this formula, or this function, or this example, I mean. And you know what, I'm going to go through one more example, maybe a smaller one, just because that one was way too easy. We're going to go with 4 numbers, and if you totally understood how this algorithm worked, and maybe you just, if you just needed me to get out of the way so that you can copy it, feel free to just pause the video. What I'm going to do now is I'm going to do another one, just because, yeah, that was really easy. It was too simple for some reason. 10, 5, 12, 7. Okay, kind of mix these up a little better. But we're going to do 4 numbers this time, just because we're trying to get through this faster. So this is the original call. And yeah, of course, if you're already gone, goodbye. Subscribe and like the video. and email me if you have specific ones that you want me to go over. Left is 0, right is the full length, or the last index 0, 1, 2, 3. Pivot number, and partition index. Pivot number, let's pretend is 7. Sometimes, I mean, this is supposed to be random, right? And it can do 7 because we let it include the max. Let's see. And so now we use this numbers to go into the partition function to create our partition index. And so left was this, right was this, and as long as left is less than or equal to the right, we are allowed to go in here. Is left less than the right? So is that less than the pivot number? No, it's not, so we don't get to go into that while loop. Is the right greater than the pivot? No, it's not. It's not greater than the pivot because it's equal. We don't get to go into that while loop. So is left less than or equal to right? Yes, and we swap these. So let's do a 7 here and a 10 here. So that's that. And we increase these, so left moves, right moves. And so that goes to a 1, that goes to a 2. And now we check the outer while loop condition. Left is still less than or equal to the right. And so now, is this number 5, is that less than the pivot? So is 5 less than or 7? Yes, it is. So we go into that while loop and we move it. And we check again. Is left less than the pivot? This is no longer less than, so we exit out of that while loop. And the right or the left turned out to be a 2 now. Okay, is right greater than the pivot? Is that greater than the pivot? Yes, it is. So go into there and subtract that right. Now, is 5 greater than the pivot? No, it's not. So you don't get to go in the while loop. Now our right happens to be a 1. And now we're thinking, okay, maybe we'll swap these. I mean, just from a perspective right now, we don't need to swap it. That 5 is good. We don't want the 5 and 12 to swap. So we check here. Good thing that it doesn't let us. Left is less than or equal to right. Left is greater than right. And so we don't get to go into that if statement. And pretty much, since we're done with that if, that's the last thing in the while loop. We have to check the condition again. Left is less than or equal to right. No, it's greater. So we return the left, which is a 2 here. That's our partition index. That call, we just did this here. And now we'll use that to create our our call 1 and call 2. So let's do this. Number 1 and number 2. Left, right. All right. So that left, what is that? That is talking about this left here, or whatever it was before we hit this. That left becomes it was a 0, and the right was, or right is now this. Kind of, these are the values that are going to go into this function call. The left was 0, right is going to be partition index minus 1. That's a 1. And for our second call, partition index is a 2, so straight up 2. Right was going to be a 3. And we already know, just looking at these numbers, make sure the left and the right, left is less than the right. Good, so we can go ahead and do both of these calls. And let's go ahead and do number 1 first. Number 2, let's save it in here. Left is 2, right 3. We haven't picked a pivot, and we haven't picked a partition index. So let's get this out. Left 0, right 1. That was a 7, right? All right, so once we're here, we have our left and right. What we haven't decided is what our pivot is. And now we cannot pick a pivot within this outer array. We have to simply pick one from the inner, from our now, what our parameters is. And what is our max and min? It is a 0 and a 1. So pretty much we get to pick from 0 and 1 what our pivot is. And that's the whole idea of not really chopping the array into smaller parts, but rather really clamping down on the parameters so that our scope is smaller now. And so now our pivot point is only here. Essentially, we're running QuickSort on this small section anyways, or only this small section, because we don't want to run it on the big thing again. We just did that. And so now let's pretend we have 5 as our pivot number. And also to reiterate how we have our whole array, but we're only kind of running QuickSort on a smaller part of it, is how the partition helper function works. We are calling on the left and the right, and let's look at our left right now. Left happens to be at the 0, right is at the 1. And so we know that our arrows are only going to move inwards or towards each other, and so we know that it's never really going to have to play around over here, because once we're here, we know we're done. We could come out. And so once we're at the partition index, or once we're in the partition function, we check, okay, left is less than right, while this number is less than the pivot, and that is not, so we don't go into the while loop, that stays. While this number is greater than the pivot, is that greater than the pivot? No, it's not, so we don't go in there. So the left and right stays. Is left less than the right? Yes, it is, and so we swap these. And so the 5 and the 7 changes, and automatically left increases, right decreases. And now we go over the bigger outer loop. Is left less than the right? And that is no longer true, so we return the left. Left is 1, so our pivot partition index is 1. And you can see how this is kind of coming along. We have to sort of do the same thing on that side. But before we do that, this will result in 2 calls again. Simply because, remember, we did this call, and next one in line is this. However, this also deserves 2 calls, simply because once this function finishes that partition index that we just did, we go through these 2 lines of code. And so now left, what is that? Left was that original left, which was 0. Right is now partition index minus 1, so that's a 0. And for this call, partition index is a 1, and the right is what the original right was, which is a 1. And so now just looking at these values here, we know that once this call, so let's say this starts calling, it'll go through this line down here, left is less than right. It is equal, so it's going to skip this whole if statement and go right to returning the array. Since this is not returning this function call, it'll just do nothing. And so that will be a dud. Same thing here. For the same reason, that'll be a dud. And since this function call happened, we can now go run this one. All right, so 2 and 3. 2 and 3, that's what it was. And I'm going to, that's the 5 and the 7. Just clean this up a little bit. And I'm leaving these numbers here because, again, the idea of how our function calls are mutating the original array versus creating new ones and replacing them. And so let's see. We're going to pick a pivot point, but our pivot point can be only picked within here. The 2 and the 3, 0, 1, 2, and 3. Those are the indexes. And again, that reiterates how we are calling QuickSort on a smaller subsection of the original array, and we keep on doing that. And so here, we'll pick a pivot point. Last time we picked, it was 7 and 5, and we picked a smaller one. Let's pick the 12 this time. And so that's our pivot number. Our left starts at 2, and our right starts at 3. And so let's go ahead and follow this. Left is less than or equal to right. Yes, we get to go in here. Is left less than the pivot? Is that less than the pivot? No, it's not. We don't increase. Is the right greater than the pivot? It is not greater, so we don't go in there. So now as long as the left is less than the right, we swap these. And you guys might be able to hear my voice is getting kind of hoarse, or bear with me, we're almost done. And so now we made the swap, we increase the left, we decrease the right, and so left goes to 3, right goes to 2. And again, we go look at the outer while loop. Is left, as long as the left is less than or equal to the right, we get to go in here, but it's not, and so we don't. We have to go out, return the left, which is a 3. And so now this one will, again, do 2 calls. Because we were in here, we just picked the partition index, and now we have to do the left and the right of this guy. And so what is the left and the right? The left is going to be whatever that original left was, which is a 2. And the right is partition index minus 1. This one, okay, minus 1, so that's a 2. This one, partition index is a 3, and right, which was a 3. And for, of course, the same reasons as the reason the other one failed or were duds, these are equal to each other. These are equal, and so we know that once we, even when we do, so this number 1 was this number 1. So that was number 1 and number 2. When I end up calling this guy, what will happen is left is not less than the right. It is equal, so we're just going to return the array. That's going to be a dud. And again, to say why it's a dud is because these functions are simply running. They are, as a side effect, we want it to mutate the array, but if it doesn't go in here, it can't mutate the array. It's just returning that. And it doesn't matter really what we return for these inner function calls or recursive calls, because the whole point of the recursion here is that it mutates the original array. And when we return, it doesn't matter because we're not returning this function call. Same thing for this 3 and 3. It's not going to go into this if statement, and so that's going to be a dud. And we are finally left with what we have. All this hard work that we did with the recursive calls was for the sake of mutating the array as a side effect of running those functions. And look what we have here. We have 5, 7, 10, 12. That is a fully sorted array. And pretty much we'll return the array at the very end, and we're done. And so I'm glad that one had a little bit more going on than the last one, which was just 2 swaps. So that is QuickSort. Hopefully you guys understood it. If not, take a look at the code. I encourage you to copy this into your REPL or just a JavaScript file and run it with all these examples, different examples that you can think of. It should take care of everything. And if you have any questions, be free to put them in the comments. And if you like the video, please like, comment, and subscribe, and I'll catch you in the next one. Thanks.